Hey all, welcome to my channel. In this video, we're going to learn about Uber system design, both at rider flow and also at the driver flow. So let's watch the video, to explain how Uber works. Then we can basically go step by step. Okay. So I hope you guys basically watched the video, right? I think you got the sense of what we are trying to design. Now, this is the problem statement, right? So we all know like cab booking system like Uber or Ola or Rapido, which is basically popular in machine coding and LLD problems. Our goal is to design an Uber-like system that supports both rider flow and driver flow with realistic behavior such as OTP verification, surge pricing, and cab assignment. So this all we are trying to build in this video. I will basically record this video in two parts. So part one is mostly tries to cover about rider flow, and part two will also add the existing rider flow with driver flow, OTP verification, and other basically enhancements like surge pricing, everything. So the goal is to be code should be extensible, object oriented, uh, and runnable with basically sample simulations. And this is the most part to differentiate the existing videos of machine coding and LLD videos of Uber, right? So if you are new to my channel, so please subscribe and like the channel. So I'm consistently uploading the machine coding and LLD videos. In future, I'm also planning to upload system designing videos as well. Now let's understand the core functionalities, right? So first is basically rider flow, and we have the driver flow. Like so, rider basically registers and sets the current location, right? So what will happen? So first, let's understand the scenario. So rider basically sets the current location as well as sets the destination location. And once riders enter the destination location, we basically Uber as a service do the fare calculation for the different what do you call different vehicle types. For a bike, it will be 100 rupees. Maybe for a scooter or auto, it will be 400, and for car, it will be 600. There might be multiple vehicle types like a sedan, Uber Go, or like XL. So depending on the vehicle type, it will basically show the fare of the destination location. So this is basically Uber calculates based on like predefined ML on the road, what is the fare previously charged kind of thing. But yeah, once this experience is completed, next is basically, let's say if I am the user who wants to take a ride of a Uber, I'm selecting a car, right? Now what Uber will do, it will basically sends the request to the drivers. So in the back end, Uber might send the request to the, let's say, three to four drivers, or depending on the geographical location where the where the driver is available nearest to the user's current location, right? So now one of the driver basically accepts the ride, right? So now what will happen when, as soon as basically driver accepts the ride, rider basically gets the one-time password, right, for the security measure. So once we basically enter the one OTP, once we basically tell the OTP to the driver, then only ride is a progress. So when finally ride ends. So this is the user journey which we saw in the video and now also have explained. So here also I explained same things. One is basically rider flow. Rider registers and set the current location, and rider selects a destination, right? System displays available vehicle types with estimated fares. Rider choose vehicle type and books. OTP is generated. A rider shares the OTP with the drive with the and to start the ride. So here you should also know, like, yeah, let's go one by one. Let's also see the high level driver flow also. Driver registered and linked to the club. So first thing, driver has to register with our service, right? So driver details also need to capture. And when the rider books, all we need to fetch the nearest drivers only. So driver to accept to get the booking. Driver enters the OTP, and only driver can end the ride. So, and these are all the business rules like OTP verification, cab availability, and fare calculation, everything. So one thing you guys needs to understand in the machine coding round, no one expects the fully extensible production ready code, but at least you have to demonstrate whatever resource, like what within a time. For example, generally machine coding rounds are 2 hours. In 2 hours, you have to demonstrate. Okay, these are the you have to identify the classes, identify the services, and also fields and the relationships, everything, and then completing the minimum basic features to get eligible or basically to get selected in the machine coding rounds, right? Now, what is our main thing? Let's identify the entities. So here I'll do the live coding along with you. Which basically helps you like about how I'm basically thinking, right? So now let's go with the rider flow. Now in this video is a part one. Let's complete the rider flow. In the second video, I'll explain the driver flow and OTP generation, everything, right? So first, what exactly we are required, right? First is required the rider object, right? So rider object is nothing but it's a basically simple. You can have, so I'm the rider, so I can basically Uber. I can basically give a sign up, right? I can log in the username, password. So I'm ignoring all these complex extra fields which might not be required in this video or a machine coding round as well. So most important thing to uniquely identify is basically rider ID, and then name to display. And also the most important thing, rider basically sets every time is nothing but current location, right? So this is the one we need to capture: rider name and current location, rider ID. So we are done with the rider. So now let's take a location field, location poso. What exactly location will contain? From latitude and also to latitude, right? So location basically nothing but a lat long. So to exactly pinpointed the location, we basically needs to give the from and to. So now what else we have? Next is let's say cab info, right? So cab has a ID, cab will have a driver name, right? And cab will have a location. So which in cab is currently is in which location, right? And also is cab is available, right? And also we can also have vehicle type. So vehicle type. So now let's implement this vehicle type as well. So in this vehicle type, what else is required? It can be like let's say sedan or like Uber Go or like auto, right? Or bike, whatever, right? Vehicle types. So now, okay, these are the high major things at the our initial poses: rider, location, cab, and vehicle type. Next, what is the most important thing? Basically, it's like we need to book, right? So we require a booking object. In this booking object, this is the most important thing. We require obviously booking ID, and here we require the rider details and what are the cab. So in this cab, we don't need to maintain the driver name, everything separately, because in the cab, the driver name is already covered, right? Vehicle type, everything will be covered. So we just need to enter the pickup location, right? Think like a user perspective, right? What all fields which are required. So we need to design in this way. So let's have a destination location as well. Yeah, and also let's also keep track the booking time, right? So generally booking time it might be differ that than the ride start time and ride end time. So it will be booked, but so driver can be at like 2 kilometers away or 3 kilometers away to reach you, right? Whenever driver enters the OTP, then only ride start time will happen. So these all complexity we'll discuss later. First let's build the basic basic Uber application, right? Um, I think, yeah, another important thing basically let's just fare for this ride, and also booking status, right? Is it like in processing, booking confirmed, or booking progress, or booking completed, or booking failed or cancelled, whatever, right? We need to track the status. So yeah, I think these are sufficient, I believe, right? um, Hey, I'm recently on the bonding. I'm taking so for the and bonding basically offering the best features for the students also. For example, if you want to take the one-on-one mentorship, but if you don't want to pay the like 600 rupees, right, for 45 minutes session, or if you don't have that much money, basically bonding has a feature for the students exclusively. If you are a student, you can basically verify your email ID, like while booking my session. For example, you want to book my session, let's say for tomorrow. Let's say you can click on continue, right? You can just verify your student email ID. Once they verify, automatically 25% will be applied, right? So this is the one of the good feature provided by the bonding, which I am currently utilizing. So if anyone wants to have a one-on-one session with me, or students who cannot afford the big prices, for example, this is a quick chat. It is basically 500 rupees. This bonding has a good feature which I'm basically providing for the 50% off for the students, right? And people who wants to take the interviews with me, like, right, you can always reach out to me. You can basically follow to get my latest updates on any services or any courses. Okay. So why I'm basically not keeping the setter for location, right? Okay, before that, let's have the location class. So here, so in the location we have basically string. Okay, sorry. X coordinate, right? Private final double y coordinate, right? Let's quickly create the constructors and getters. Okay. Right, so we are done. So now let's implement this location over here. Current location, let's capture the current location. So why I'm basically using the final for the rider ID and name, and not for current location, because current location is something basically sets. It's a mutable operation, whereas ID and name basically initialize at the beginning only. So that's why I'm doing while constructor initialization. So it's up to you how you basically build this particular part. But these two are important, should be initialized. And location, we generally basically whenever user opens the app, right, that time yeah, that time they can basically set. Yeah, correct, I think this should work. Yeah, I think this should work. Now what else, we have the cab. Okay, so in the cab, let's quickly write driver name. You can also mention cab location as well, or location like is available. Okay, we have to write the vehicle type also. Okay, let's refactor vehicle type. Let's have like maybe bike, or you can simply say two-wheeler also, like, but yeah, bike, auto, sedan, right, SUV, yeah, whatever, like, yeah, how many you have to, you want to keep. And now let's have vehicle type. Now let's have private. Okay, private. What is another one? Like, I think start time, right? Sorry, I think Cab won't have start time. I think this should be sufficient. Vehicle type, everything should be sufficient. So here also for the cab, ID and driver name is basically required. I think vehicle type also can be part of constructor only. Let's have the vehicle also final. So rest, I think location, everything it's fine. Like you can initialize constructor, but sorry, no, is available, but location you need to basically continuously change, right? So that's why I'm not keeping final for them. So now let's generate a constructor. For now, we can just enable for all if you wish. For but getters anyway, let's uh, keep track only for them. Yeah, correct. I think this should work. Java class. Now, what is important thing? It's booking, right? So what all important? What all things are basically general booking? Okay, ID rider cab. Okay, okay. Yeah. So let's quickly do this booking one. So first is basically required. Um, so rider won't change, right? So it should be final. Next is basically also while booking cab also won't change. Generally, booking is basically immutable, right? Uh, Majority of fields. So let's have booking location. Let's say pickup location also shouldn't be changed. Generally you can change, but the pickup location whenever you select it will always show that one also, that one only, right? um, Destination location, or you can just simply say like a drop location. Simple, better one naming. um, Next is basically booking time, right? Let's have local date time. And another important thing basically, let's say private final, let's say um, okay, here into calculate fare rate. So fare can be changed dynamically. Initially it might show some fare, but later due to surge or like heavy traffic it might change the another fare. Let's have the fare as a normal only, like which can be getters and setters. And also booking status, right? So we need to create the booking status. So booking status, it could be simply like uh, created. For now I'm just using created, started, ended. This cancel and all you can basically maintain a different APIs, but that's out of yeah. Well, so now I think we have covered everything. Let's initialize the constructor. Um, let's generate the constructor. uh, Constructor, yeah. Let's have getters and setters also. Cool. I think this is also done. I think our classes are done, right? So now let's build the service. So what are the services required? One is to store the rider details, which require the rider service, right? Let's list all the services. And what else is required? Next is to store the cab details also. Let's say we require cab service. And what else is required? We require the booking service also, right? To capture the bookings. Hmm. Now let's have rider service, right? So ideally, here we can also maintain, for example, we can create the Pojo like a DAO layer, create the repository and create the rider repository like cab repository and booking repository, and you can basically use the what do you call like a solid D dependence injection at the rider service as a rider repository, for booking service booking repository, cab services cab repository. So that will also be, that is even more extensible way of coding, right? Extensible way of clean code. So you can do that as a homework, but now I'm maintaining the simple DAO layer inside the service only layer. But yeah, for you, just maintain in the separate DAO layer as a repository package. In that, just maintain all those repositories. Like, yeah, I maintain in the map. So rider, just simply rider ID. It can be like a string. If I mention string, right? Yeah, string, and also just rider information, right? So ideally, a rider map. That's called as riders. New hash map. So public um, rider. Let's say register rider, right? What is two things are important for constructor installation? We require the string ID, comma string name, right? So rider equals to, we initialize here ID comma name, riders dot put off id comma rider, return rider, done. So similarly, get operation also, rider get rider, so string id, so we have to return the riders dot get id. So here you can also do the exception, right? You can create something like exception package. In that, from that exception package, you can throw the exception if the rider is not presented, that no such rider exception or like a bad request, whatever, right? So that makes even more extensible. But remember, in a machine coding problem, along with those kind of extensibility, but the most important is basically completion of a code. That's why first do in this way. Once you have a time, then do the all the extension operations. This is also not a bad way, right? This is basically minimum viable product way. Like this, think of like MVP, right? So now let's have a cab service. So um, private final. I'm maintaining a list of cabs. List of cabs. Yeah, what I simple, right? First is basically registered cab. So what all things are required? ID. You can just need to go to the ID, driver name, location is available, vehicle type, right? Just do this one only, like ID, driver name, okay, location, uh, vehicle type, VEH, okay, vehicle type, cabs dot add of new cab of ID comma driver name comma location comma vehicle type, okay. I think it is available. Okay. While registering, obviously it is available. So we don't need to pass as a, that is a parameter. So we can remove that one. Is available. We can keep it as true, right? So yeah, I think this should work. Next is basically, um, yeah, I think as of now, registering cabs work. So what are the other things an cab can do? A simple thing a cab can do is basically find the nearest by cabs, right? Um, so what you can do, we can basically public. So ultimately, we require a cab, right? Um, so find nearest. Okay, find nearest available cabs. Ideally, I can think like I'm basically here. I want to return only single cab, whichever is basically available first. But in the real world, what will happen? We basically fire an event to the drivers to accept, right? So here I'm whichever caps are basically is true. I'm basically just fetching that one, like so. But in the real world, we can simulate in a different way. Let's have a rider location. What is required? Vehicle type, right? Yeah, I think this should be sufficient. Now inside you need to do some logic. Um, so what exactly it will do? We need to iterate based on this vehicle type from the cabs. We need to filter the all the vehicle types, and that we need to stream whichever is available equals to true, and that one we can basically simply return, right? So just quickly draw for cabs if cab dot is available, okay, and then cab dot is vehicle type, okay, get vehicle type, okay, equals to whatever vehicle type we pass. Cool. So then we basically figured out. So here you need to find the obviously, right, minimum distance one, like so during cab, if it is, let's say it's in Delhi, I'm basically asking from Bangalore, it won't work, right? So we need to write some logic. So before for that you need to do location logic over here, public double, so distance to, so which will basically gives that what is the distance from the current location to this location, right? So location, mm, okay, let's keep it as other location, yeah. um, Double dx equals to, it's simple, like so this dot x equal this dot x it's like x2 minus x1 uh, uh, like what is the formula, right? I think square root of x2 minus x1 whole square plus y2 minus y1 whole square, right? Yeah. So x2 minus x1 whole square, okay, this is basically it's a mod, so we can ignore that minus smaller thing. So okay, other dot x, so similarly double, okay, 1 second, double dy equals to this dot y equal, oh, sorry, y minus other dot y. So we just simply return math dot square root of, okay, math dot square root of x2 minus x1 whole square, right? So dx into dx, it will automatically become minus, become plus, whole square plus dy into dy. Cool. I think this should work, I guess. And so in cab service, so in the nearest cab service, we can just simply check the distance, right? So cab dot get location dot distance to of rider location. So we basically want to get some value. So okay, okay, double. Um, let's keep track the minimum distance, right? Double dot max value. So minimum distance equals to this one. So it's a simple max find logic, minimum find logic. Yeah. So if um, this should be, let's say, a temporary variable, right? Uh, double, let's call it as a distance only. If distance is basically less than minimum distance, we require that cab. So just assign the cab. Let's call it as nearest cab. See, naming conventions also very important. So make sure you guys are doing this naming conventions also perfectly. So once you're done, now just simply return the nearest cab. Yeah. Okay. Okay. Initialize the nearest cab. Okay. Let's initialize the null. Cool. So obviously, if there is nothing we find, you can return the null or throw exception that no available drive cabs at this moment, kind of thing, right? I think this should be sufficient. Let's have a booking service as well. This is the most important thing, right? So So here for booking service, we require the rider information and cab information, right? So to check, okay, these people are presented, this rider is registered, or like to fetch the cab while booking, right? So that's why that just do the D solid dependence injection, private final. So cab service, private final. Uh, okay, rider information. We can rider service. Cool. Um, yeah. Let's uh, okay, what actually it will do. So first thing, show available vehicle, show available vehicle types. That is the first logic. So according to this one, uh, okay, show available vehicle types with fare calculation. So we completely forgot the fare. Okay, so fare, right? um where is the fare exactly in the booking, right? So booking, we need to assign the fare. Okay, and also we are displaying the fare for the vehicle. So we required something like a model, right, which will have the vehicle versus fare, which will hold the vehicle and also what is the fare, right? So vehicle fare, let's call it as vehicle fare estimate, right? The spellings actually. So vehicle, okay, vehicle fare estimate, right? So here we can basically maintain that one. What exactly required? Private final vehicle type and private final double, right? Estimated price. So initially the one we showed, right? Later it might basically get changed depending on various other factors. Let's quickly um, add the constructor and do the getters as well. Generate getters. Let's implement toString also. Like I think okay, it is not. Let's say vehicle type plus simply dollar estimated value. Okay, cool. Okay, let's ignore. Now in the booking price, we need to use this vehicle fare estimate. Vehicle fare estimate should be. So how can we integrate this vehicle fare estimate, right? Okay. So in the booking service, okay, I think here let's see how can we do. How can we show the all the available cabs, and for the available cabs we need to fetch the assigned money also, right? Assigned price. So let's have the model called strategy pattern. Let's take the strategy pattern. STREAT. I think this is the simple pattern where it can be fit in any majority of applications. Let's have a pricing strategy. So we can say one is basically, normally we can say based on the vehicle type, we can have one pricing strategy. So what could be other pricing strategy you can think of, which can be helpful in part two as well? Maybe during too much demand and supply, right? That could be different pricing strategy, like a surge pricing strategy, like which is one of the feature also, right? We discussed later that one, but yeah, in this video let's have the interface declaration. So pricing STREATEG, okay, STREA. Okay, pricing strategy. Let's call it as, instead of strategy, let's refactor and call it as basically pricing for a better naming purpose. Cool. So the pricing strategy should be interface, obviously. So what exactly it will conduct? It will calculate the fare, right? Calculate fare location from location to, and a vehicle type also, obviously vehicle type. Cool. Now let's implement this one. First is basically in this video I'm doing basic calculation strategy, like vehicle basic calculation strategy, right? So vehicle type pricing STRATEGY. Okay. Vehicle type vehicle okay. Vehicle type pricing strategy. What the okay. But yeah, it doesn't matter. But yeah, it could be like mm, yeah, vehicle type pricing strategy. VEHICLE. Just give me a second. VEHICLE. Okay. Vehicle based pricing strategy, right? So in that, we'll implement this one. We'll implement the pricing strategy, and we just override that method. Cool. Now here, mm, here what we need to do, depending on the vehicle type and depending on the vehicle type and also from location to location, we need to return some price, right? Now first let's fetch the vehicle types. So double. Mm, so what is the basically what is the base, right? um, so we can use the vehicle fare estimate as well. Let's, if we do in a simple way, let's say double, let's say base rate, right? Let's have base rate per kilometer. So in switch case, let's have vehicle type. So if it is basically what, bike, so base rate per kilometer equals to, let's say, 2 rupees. That's, if it is auto, base rate per kilometer equals to, let's say, 4 rupees, right? If it is for a sedan, go, I think. Okay, sedan. If it is a sedan, base rate per kilometer equals to 8 rupees. I think SUV, I think bigger. SUV base rate per kilometer equals to 10 rupees, right? Now we got the base rate. We just simply calculate the distance also. Distance equals to from dot distance to 2, right? So we can just simply return a base rate per kilometer into distance, which is actually simple. Initially it's basically, let's have its maybe 0, right? Or instead of doing this one, we can also have for a cleaner way, right? We can have this one, base rate per calculation equals to, let's say, maybe default could be, let's say, 1 rupee. Yeah. So we calculating the fare. So now this one we need to do the dependency injection in the booking service, right? So private final pricing strategy, pricing pricing strategy. Let's add this one. Cool. So cool. Now we can have we have the all the information. Now let's basically do the first call. Show the available vehicles. So the available vehicles, right? So it should be uh, vehicle fare estimates. Show available VE vehicle types. So just need to give the location. Location from location to. Okay. Let's quickly define the logic. It's a easy logic. So this is not like a DAS here, right? So just normal logic, relation, hash. No need to spend much of our brain also, like. So just iterate. So vehicle type dot values. So first we need to find the fare, right? Pricing strategy dot calculate fare from comma to comma vehicle type. Once you calculate the fare, now you need to return in a list format, vehicle fare estimate pojo, right? So mm, so sometimes it could be like if you want to round up by decimals, you can do math dot I think math dot round off like fare into 100 by 100, right? Or if you want the standard way, like you can use the basically big decimal also. Um, Big decimal dot value of fare. So here we have one set scale, right? So 2 comma rounding mode, you can say rounding mode up. So generally yeah, half up dot double value. Cool. So now estimates dot add of new vehicle called estimates is nothing but what, vehicle type. Okay, type comma rounded fare. Cool. Return estimates. We are done, right? So we get the estimates. Now we show the estimates to the user. What will happen next? If a user selects let's say car, and then we okay, driver. Okay, cool. In this case, a driver is out of the scope, right? So let's directly go to the book cab. Public booking, public booking book cab, right? So we require a rider information, rider comma vehicle type. So what vehicle basically rider selected, right? And also location, like drop location. Cool. So first what we'll do, we first find the uh, we first basically, so once the driver choose the vehicle type and also once the rider choose the vehicle type and drop location, like this basically triggers. Now we basically uh, get the nearest, we need to send the request to the driver, right, to accept. So here that is basically out of the scope. We basically doing the cab service dot find the nearest drivers based on the okay rider dot get location and also vehicle type. Okay, so once we basically do this one, let's assign the, let's get the cab. So you got the cab. So if cab is null, that's it. No, we are busy. Like if cab equals to null, we can simply throw exception also, like throw new. You can use custom exception, or simply for now for timing purpose I'm doing the runtime exception. Simply no available cabs for the vehicle type. So now cab. So now we got the cab. So we need to basically um, assign the we need to basically what we need to do, we need to cab we need to make it as unavailable, right? um, so so cab dot uh, set available, okay, false. So ideally, yeah, I think more better way is to do is basically um, public void, let's say assign to ride. Okay, so here we can just simply do the is available equals to true, so is available equals to false, so that we no need to, we can remove the control from the external services to access this one. So this is a cleaner way to do. So right, assign to ride. Cool. Once we done assigning to the ride, next what we do, we need to update the booking status also, right? We need to create the booking object now, and then update the booking status. New booking, what rider cab? Okay, rider cab pickup location. Okay, rider dot get current location. Uh, drop off location, right? Drop location, and also booking time. Booking time should be the same time. We can just do the local date time dot now, so that we can remove this one. Yeah, booking dot set status created. So return the booking. So let's see here, booking everything is done, right? Okay, I think we still didn't set the fare, right? Okay, this has to be set while creating the booking only. So uh, so I think which means that we required the strategy over here also, right? Okay, let's pass this one now. Maybe pricing strategy. Ideally, um, we can just simply, I think what we can do is basically we can simply do the we can simply do the double fare and do the fare over here, right? In the booking, just here we can just simply fetch the double fare equals to, we have also have pricing strategy dot simply calculate fare. We have the rider dot get current location, uh, what drop location, comma cab dot vehicle type. So this is whatever about same thing. It is the same thing only, nothing fancy, right? So I think yeah, now it's completely good, right? Uh, Now what we can do, what booking service will do, we can be simply start the ride. Set status. Mm, so booking status dot started. So booking. So actually, while starting, actually we need to create a maybe ride started time kind of thing, right? So let's maybe quickly create that one. Um, private final local date time ride start time. This shouldn't be final. Yeah, local date time ride and the time. Cool. So let's quickly do the getters also. Setters and getters. Generate. Cool. In the booking service, so booking dot set rider start time local date time dot now. That's a simple thing, right? We can just simply say ride started. So similarly, we should do the Android also. Ride ended. So instead of here set the Ride time, so ride and time, and booking is basically ended. So here we can also do the what final fare calculation, right? And also set the final fare. Booking storage dot set fare. That's why I mentioned like fare is important. Like so, I didn't do the final one. So you can say final fare equals to. So let's call the same method for simplicity purpose. Anyway, this is just simulation. Okay. Booking dot get pickup location and booking dot get drop location. Booking dot get cab dot get vehicle type. Cool. This will return the final fare as well. I think we are all set. Okay, this is not using. So here you can use whether the rider is basically existed or not. If it not existed, you can delete. So you can throw the exception. For now, I'm just removing this one. Might not be required. But you can try this one, right? Now let's have the our mental main model. This is the main. Let's have a main. So what? So first is basically rider service to have some riders. Next is what cab service to have some cabs. Next is what um, pricing strategy. We have only one strategy only. Um, let's have that one. What is booking service? Let's have booking service equals to new booking service. We here what we can have cab service comma strategy, right? I think we are all set. Now let's do one by one. Let's register first of all. Let's register the rider. Rider. Sorry, we have the rider service, right? Rider service dot register a rider. Let's call it as R1. What is my pickup location, right? Pickup equals to new location. Let's give anything. Like let's give random 10 comma 10 or 20 comma 20 whatever, right? Rider dot set current location, or you can also call maybe a better name, maybe update location. Or yeah, I think anything is fine. Now okay, right now let's say rider enter the destination location, right? Let's have the destination location equals to new location. Let's have 20 comma 20. Now let's register a couple of cabs, right? Cab service dot register a cab. C1 driver 1 new location, maybe 11 comma 11, vehicle type dot auto. So C2 C3 C4 C5. Let's say sedan, it's a bike, SUV. Okay, cool. Now we have registered the cabs also. Now let's is what so first a rider basically entered the destination location, right? So once the enter, so rider basically has the destination and also current location, so we need to show the fares, right? Booking service dot show a vehicle, show available vehicle types for the pickup comma destination. Cool. I think let's say fare estimation. Let's called maybe list. Let's print for a real world simulation. I think okay, just printing E should be sufficient. We already has two string over there, right? Correct. So now let's say now what will happen? Step four, a rider basically selects the vehicle, right? So let's say vehicle type. Selected vehicle type equals to vehicle type dot maybe sedan. Well, let's have two sedans. Let's see which one is comes first. Ideally, 10, 11 is come should come. Okay. Now what happened? Now we need to basically book, right? So sorry, booking service dot book a cab. Book a cab. We have the rider. We have the selected vehicle type. We have the destination. Cool. If any the only thing it can catch is basically runtime exception. Booking failed. P dot. Okay, cool. Now booking service dot start ride. We can just say system ride is in. We can just have some kind of threading as well, which will wait for some time. Maybe what you can say. Let's say let's wait for maybe 5 seconds maybe. Let's simulate that one. Simply what I can do int I equals to I less than 5 I plus plus. I can simply do the thread dot wait maybe, right? So thread dot sleep of for 1 second. So every loop 1 second, right? So which is nothing but catch interrupted exception. This won't happen anyway, just for simulation purpose, right? So we can just simulate something. After direction move left yeah, just for fun. Cool. So now it will basically wait. So now reach to destination ending ride. Booking service dot end ride. So ideally this end ride start ride has to do from the driver, right? We'll discuss this one later, right? So I think this should be sufficient. Let's have a final summary. Final summary present in booking, right? Booking dot to string is not there. Okay, let's run this one. Yeah. Okay, this one let's implement. Let's quickly implement the some to string public void maybe summary, right? Next is maybe a dot driver name. Pickup, right? Yeah, pickup location. Drop. So drop location. Okay, this is important, right? Which vehicle it took? Ideally, our expectation it should be sedan. Um, cab dot get vehicle type. Fare also. Time. Let's call this summary. Okay. Okay, location also not to string. Okay, but vehicle is sedan and fare is also 113 rupees. This one, right? Yeah. Pickup location. So ideal expectation it should among these two sedans it will choose the this sedan 1011 very near, right? Okay, okay, pickup. Yeah, I think it has chosen the this sedan only. Yeah, correct. Cool. So I think we are basically completed this one. Next, in the next video, let's focus on like what are experiences we have to cover. Right, driver accepts the ride, and the OTP generation is the main part, and ride in progress, and driver ends the ride once the ride is completed. So and also we also see the some more important things like pricing strategy. Like among that important thing basically. Um, Yeah, fair calculation, surge pricing, and also OTP verification, and also rider flow, right? These all things we'll see in the next video. So if you like the video, so please like and subscribe, and share to your friends who are learning for machine coding and LLD videos. Thank you. We'll soon meet in the next video.